Hey students, I wanted to record this really quick video for you because there's one more gas law that we need to talk about. Now, we talked about Boyle's law, Charles's law, and Gay-Lussac's law, and in all three of those, one of your three variables had to stay constant, either constant pressure or constant volume or constant temperature. In the real world, whenever a gas changes, very rarely does something stay constant. In reality, almost everything will change. So I want to introduce you to the combined gas law, okay? And that's this right here. It's P1V1 over T1 equals P2V2 over T2. Now, if you have sharp eyes, you might notice that basically this is all three of the laws we've talked about so far just kind of jammed into one thing. Another way that it can be written is right here. P1 times V1 times T2 equals P2 times V2 times T1. And you're going to use it just like you've been using your other gas laws. If you're given a problem, you're going to read through it. You're going to make yourself a tree to identify what each one of your variables are and figure out what it wants you to solve for. And then you're going to algebra your formula to where the thing you're looking for is by itself on one side of the equation. Now, the truth is you really just have to remember this law. You can forget about all the other ones because all the other ones are here. Let's say that you've got a situation where the temperature stays constant, Boyle's law. Well, if the temperature is constant, then what you can do is you can just pretend that the T's aren't there. And so then you're left with Boyle's law, P1V1 equals P2V2. Or if the pressure stays constant, like in Charles's law, then you just pretend that the P's aren't there. And there you've got V1 over T1 equals V2 over T2. This works also if you've got it written this other way. Let's say that it's Gay-Lussac's law and volume is staying constant. Well, then why are you out in front there, though? That's weird. Then you would just pretend that the V's don't exist. You know what? Let me just kind of scribble over those dogs real quick. No, I'll just put some new sticky notes on there. Sure. And let's do it again. Hey, there you go. Kinda. So here, if the V's stay constant, then look, we've got P1 times T2 equals P2 times T1, which is Gay-Lussac's law. So the problems that you're going to be trying to work today, some of them are going to be Boyle's, some are going to be Charles, some are going to be Gay-Lussac, and some are going to be combined. You have to read through there, identify the variables in the space that you've been given, and then start with one of these two formulas. Nope, that didn't work. I've got a new toy here I'm trying to figure out. It's not working great. Start with one of these two formulas. If you like the fractions, then go with that. But I'm thinking most of the time you're going to want to use this one right here. It's really going to be easier for you to, start canceling things. Let's say that, let's go ahead and trash that. Let's say that you've got a problem where you're trying to solve for V1, okay? So if I want to get V1 by itself, I'm going to cancel by dividing, just like I've been canceling by dividing. You see here, V1 is being multiplied by P1 and T2. So if I want to get rid of P1 and T2, then I divide both sides by P1 and T2, which on this side is going to end up crossing off your P's and your T's. So all you would do at this point is plug in your numbers for this side over here. Remember, you're going to multiply by everything that's on top. You're going to divide by each thing that's on the bottom. Okay, that's my fancy divide sign there. And just give it a try. See what happens. Worst case scenario, we'll talk more about it later this week. Okay, so give it a try. I wish you all the best of luck. Try.